Bảo Thanh. Okay, so from now, I will share my screen again. Okay. Okay, so from we have some review questions or review slides of lecture 1. Okay. So here, just let you know, we have the motion diagram, okay, for 3 cases, okay. So if we observe the position, okay, of this guy, we have the same distance. We have the same distance mean he has a constant speed, okay. Yeah, okay. So this skateboarder has the same constant speed during the times, but for this one, distance is small and this distance is larger and small larger. So that means the speed is running out. Okay, the speed is increasing. Okay, so now the distance is far and then shorten and shorten. Okay, so the speed is slowing down. Okay, the space A is slowing down. Okay, so yeah, just let you know, when we observe the motion diagram, you can analyze some physical parameters. Uh, for example, speed. Okay, the distance and blah blah. Okay, so look, we have another motion like this. Okay, this is a non-linear, right? Non-linear curve. Yeah, so that means we need 2 dimensions or more dimension to indicate the motion. Okay, so if here we have y-axis, here we have x-axis. Okay, so you can evaluate the velocities of this pole. Okay, this is v. Okay, and then you can get the vx and the vy. Okay, blah. Okay, yeah. Yes. Okay. Yes. Yes. Okay. So this motion diagram shows the motion in 2 dimensions because the curve is non-linear. So if we look at this one, the curve is linear. We just follow x-axis direction. Okay, x-axis direction. Okay, x-axis direction. Okay. So look, we have some multiple choice questions. 2 runners jog along a track. The position are shown at 1 second interval. Okay, which runner is moving faster, A or B? You have 1 minute. Try to think about your answers. A or B? We have we have the same interval. Okay, 1 second, but for 1 second we move from here to here, here to here, here to here. We have the constant speed, but after 1 second you get a distance here, and after 1 second you get a distance here. So that means runner is moving faster. Okay, yeah. So continue. We have 2 runners jog along a track. A track. The times at each position I show here. Okay. So which runners is moving faster? Okay, 1 minute. Think about it. A or B, or both runners. Okay, runner A, runner B, or both runners are moving at the same speed. Okay, you have 1 minute to think about the answers. Okay, so the answer is C. Why? Because 0 second, 1 second, 2 second, 3 second, 4 second, 5 second, 6 second, blah blah blah. Okay, this is seconds. Okay, yeah, the unit of times. So from 0 to 2 seconds, after 2 seconds they move 10 meter, right? And after 1 second, runner A move 5 meter. Okay, so if they hold 2 seconds, they also run 10 meters. Okay, right? Yeah. So the answer is 5 meter. Okay. Yeah. This is the time. Okay. So the answer will be C. Both runners are moving at the same speed. Okay. Continue. Okay. So now multiple choice. Okay. You try to practice because for the final exams you have multiple choice questions. Okay. So you think about this one. Given vectors B and Q, what is B plus Q? Okay, 1 minute, please. Now, for now we have 3 0, so 1 minute, 3 and 1. Okay, PM. Try to think about the answers by yourself. Maybe, yeah. And then, okay. So now, when I show these questions, okay, you type your answers into this the chat. I mean, the chat window. And if you are the first person, you are the first person to get the correct answer, you get some extra power. Yeah. Okay. Okay, this is B and this is Q. So if I translate Q here, you get here is Q. So B, yeah, B plus Q, you can get okay, the vectors like this. So of course this is the answer. Okay, question 9, because the same, this one the same. So question 9. Okay, so one more. Oh no. Okay, you finish. Okay, so this slide just a review what is scalars, what is vectors. So scalar, we just focus on the magnitude. And if we have the vectors, we consider magnitude and phase angle. Okay, magnitude and phase angle. For example, vector A, we consider magnitude A and the phase angle phi A. Okay, so now we finish lecture 1. So maybe I check whether you have some answers. So it is option A. Yeah, you are correct. So you get 1% extra point. Phan Quân. Okay, so let me check. I have this list of okay, I have the list of students here, and I will give you from yeah, or maybe it's TA. Okay, please help me. Okay, and okay, so even when you have yeah, when you have 30 minutes to ask TA, okay, remind him to give you 1% extra point. Okay. Is it clear, Anh Quân? Phan Quân? Okay. Okay. Remember, yeah, this is your advantage. Okay, your benefit. So please add 8. Okay, to add 1% extra point. Okay, 1% extra point is very important. So if your final exams you get 44%. You fail this course because you should get at least 50%. So if you have one more percent, so 44 plus 1, you get 45, and I will make round up. Okay, but round it off so you can get 50%. You pass this course. Okay, so try to get more extra point. Okay, they try to get extra point as much as, yeah, as many as possible. Okay. Okay, so yeah, of course we have many multiple choice questions. Okay, to let you have more opportunity to get extra point. Okay, so now we finish lecture one. Now we yeah, we go to lecture yeah, lecture two, right? Yeah, okay, it's a lecture two. So now we come to lecture two, part one. We discuss about particle, okay, kinematics, okay, motion along a straight line. Okay, we discuss a straight line first. Okay, so for any object, just follow x-axis, x-axis or y-axis. Okay, only we say straight line. Okay, straight line or straight motion. Okay, so motion along a straight line, or I just say the straight motion. Okay, yeah. Now learning outcomes. So when we finish lecture 2 part 1, you can understand average velocity, instantaneous velocity, okay, average acceleration and instantaneous acceleration. Okay, how to interpret how to interpret graphs of position versus times, velocity versus times, and acceleration versus times for straight motion. Okay, so how can we modeling, how can we get modeling um, of physical motion, okay, with constant acceleration. Okay, and how to analyze the straight line motion when the acceleration is not constant. Okay, so I hope when you finish to part 1, you get these knowledge. Okay, these learning outcomes. Yeah, so of course, you know what is kinetic, kinematic from high school. Okay, so here we have the definition. So kinematics is the branch of mechanics that describes the motion of physical bodies. It is distinguished from dynamics, which consider the relationship between the motion of the physical body and the force. Okay, that means you need to analyze the internal force or external force imparted on the object. Okay, imparted on the body. Okay, yeah. So for models of physical body that may be considered mathematical weight of for the purpose of mathematical and physical analysis. Okay, yeah. So here, uh, where is the particle relative to a chosen reference frame? Okay, remember that when we analyze any motion, when we analyze position or velocity or acceleration, okay, you need to use reference axis. Okay, you need to use reference axis, or we say reference frame. Okay, so normally we choose y-x coordinate, y-x coordinate to becomes the reference frame. Okay, so that means if we have the object here, if you stay here, you can follow this direction, you get positive, and if you follow this direction, you get minus. Okay, negative. Okay, you going up, you get positive. Okay, going down, you get negative. Okay, yeah. So any motion, okay, you need to refer to the reference frame, the reference coordinate, xy coordinates, xyz coordinate. Okay. How fast is the particle moving, and in what directions is it moving? Okay, so it depends on the velocity, the position, okay, the acceleration. Okay, you can get what is the direction of the object. Okay, what is the distance of the object? Okay, so on. So to what extent and its which direction is its motion changing? Okay, yeah. So maybe sometimes we go upward and then backward. Okay, upward, backward, blah blah. Okay, yeah. So it depends on three important physical parameters. Okay, what are they? So they are position vectors, velocity vector, and acceleration vector. Okay. So yeah, that's it. Kinetics, kinematics. Okay, kinematics. Vietnamese meaning là động lực học. Okay, yeah, yeah. And normally we use the graphs to indicate the kinematics of any object. Okay, for example, here this is x. Okay, x is position. Okay, this is times, or we can say position versus times. Okay, and this is velocity, and this is times. Okay, so maybe we get the non-linear relationship between position and times, or here you get the linear, right? Linear, the linear, the linear relationship between the velocities and versus times. Okay, so if position is non-linear like this, okay, so velocity will be linear because v is dx over dt. So if x is quadratic equation, okay, if x has a quadratic equation, okay, so when we take the first derivative of position with respect to time, you get the v, so v will be linear. For example, we have xe 5t squared plus 2t plus 9. Okay, this is a quadratic equation. Okay, so when we calculate v is the first derivative of x with respect to times, you can get 10t. Okay, plus 2, right? So this is a linear equation like this, and this one maybe here is like this. Okay, it's like this. Yeah. So velocity is e this love of the position graph. Okay, so acceleration is this love of the velocity graph, right? So when we calculate a from the high school, a derivative of v, right, velocity with respect to times, or you can get the x, okay, d square x over dt square. Okay, we take the second derivative of x with respect to time, you also get acceleration, or we take the first derivative of x with respect to time, you also get acceleration. Okay, yes. Any questions so far? Okay, so let me check whether we have some questions. Okay, so continue. Yeah. And you know, for if we know the curve of Vx, for example, at the time here, we say Ti initial times, and this is Tf final time, initial times. This one is final times. Okay, so for these areas, E delta x distant. Why? Because we have Vxe dx over dt. Okay, so if we modify a little bit, you get the Vx times dt e dx. Okay, and then I take the integration. Okay, so I take the integration of dx, you get x xe, the integration of Vx dt. What is it? This is area, right? The integration of Vx from Ti to Tf, this is x, like this. Okay, so when we take the integration from Ti to Tf, you get these areas. So this area is distant. Okay, yeah, distant. Yeah. Okay, so like I mentioned before, when we analyze the position, okay, we need a reference frame, or a reference point or the origin. So, okay, so here is 0, here is 0. So that's mean here is y and here is x, and this is origins. Okay, 0 mean origin. Okay, so if the car here, does mean they get positive. How many miles from the origins? 4 miles from the origins. So if you consider the position of the cow, so if you stay here, so if you stay here and you look back to the origins, you get -5, right? Because if we follow the direction, this is the arrow, so that means here is minus infinite, here is positive infinite, minus infinite, so if you don't know, if you don't have xy coordinates, okay, you cannot make the comparison between this cow and this cow. For example, if here is x and y and the origins will be here, okay, so that mean the distance of these cows will be positive, maybe a, and this position of car when we compare with the origins also positive b. Okay, so it depends on the reference frame, it depends on the xy coordinate you have chosen. Okay, yeah, and we can get a distance from the origins and also the direction from the origins. Okay, yeah, so if we have the origin here, so the position here, the direction of the position is positive, and the direction of the position here is negative. Okay, yeah. Oh, sometimes we say just coordinate systems or xy coordinates, because we also have positive and negative direction of the coordinate systems. Okay, I hope you understand. Any questions so far? Any questions? Let me check. Okay, no questions. Yeah, just theory, so maybe you have no questions. Okay, yeah. So look, the symbol that represents a position along an axis is called the coordinate, right? Here, this is 0. So this is y, this one is x. Okay, so if we consider that person, okay, that means she is 20 meters from the origins. Okay, so that means here is distance. Okay, displacement. Later on, I will let you know what's in the difference between the displacement and distance. Okay. Yeah, what is the displacement? Okay, 20 meters. And she will finish at this point 50 meters. Okay, so that means she will have 30 minutes left, 30 meter left. Okay, to get this destination. Okay, yeah. So that means they follow. She follows straight motion. Straight motion. Okay. Yes. Or we consider times. Okay, look at this one. Okay, the this bit is constant. Okay, or not constant. Why? Because the distance here is large, and then reduce gradually. Okay, yeah. So this bit, this bit is slowing down. Okay, yeah, during the times. Okay, or here, the same. Yeah, but different origin. So here this is TA0, so that means here is origins x y, this is origins. Here we don't use x, we use the time t, okay, because 1 second, 2 second, 3 second times, yeah. So times is coming to positive values, right? Positive values, yeah, from 0 second to 8 second, and then now look, this is 0 second mean the starting times, okay, the starting time, okay. So here is y, here is x and xe times, okay. So the units of x-axis is times, okay, yeah. Okay, so now for this is 0, so this is y-axis, this is x-axis, okay. Maybe I draw this one is will be here, okay. This is x. So at the beginning we are here, okay. How many meter, how many feet from the origin? 50. And after sometimes delta t, okay, you get that point, okay. So that point, that means 150 feet from the origins. So what is the distance? So distance is displacement. So the displacement is xf minus xi. So xi is initial displacement, okay, and xf is the final. So xf we have 150 and xi is 50, okay. So you get 100 feet, okay, yeah. Yeah, so what is displacement? So displacement is the difference between a final position and an initial position, the initial position, okay. So now, yeah, so when we mention about displacement, okay, you should consider coordinate system, xy coordinate. So if you don't have coordinate, you don't have displacement, okay. And here the definition of displacement, the change of position is called a displacement. Vietnamese meaning sự chuyển dời, sự dịch chuyển, okay, yeah, displacement. Okay, here example, we need to consider the changes in times, which we call time interval. Time interval normally we use delta t, e tf minus ti. Tf mean final times and tie initial times, okay. So at the beginning we are here, right? Why? Because this is 0 second or 0 feet, okay. So this is x-axis, this is y-axis, okay. So at the beginning, okay, we are at 0 feet and 0 second, okay, and you get 20 feet when you get 1 second, and 2 seconds you get 40 feet, so on, okay. And then if you get 6 seconds, we have 120 feet, okay. Now you think about y-axis is x, distance, okay, y-axis is displacement or the position, okay. Actually you just say position. So if x-axis is position, sorry, y-axis is position, and x-axis is times, okay, again, x-axis is times, y-axis is position, okay. And then how many seconds we consider? 0, 1, 2, 3, 4, 5, 6. This is 0, 1, 2, 3, 4, 5, 6. Okay, so if you have 0 seconds, 0 feet. 1 second, for example, here is 20, 40, 60, 80, and then 100. So 1 second, you get 20 feet. 2 seconds, 40 feet. 3 seconds, 60 feet. And then for 3 seconds, 60 feet, and 4 seconds, 80 feet. And 5 seconds, 20 feet, and 120. Okay, so very lucky because this one is linear. This one is linear relationship. Okay, between x versus times position versus times. Okay, I hope you enjoy it. If you got it, any questions so far? Okay, so because we start at 1:15, so we will finish the lectures 3:45, and you have 30 minutes with TA until 4:15 p.m. Okay, so now we have 15 minutes left before we finish the lecture today. Okay, so look, our time interval delta t measures the elapsed times as an object move from an initial position xi at the time ti to the final position xf at the time tf. For example, if here is ti 1 second and here is tf, okay, so we have delta t how many seconds? 1 second, because delta t is tf minus ti. Okay, for example, ti is 1 second and tf is 2 seconds, so 2 minus 1 you get 1 second. Okay, how about x 20 feet? Okay, so if delta t is 1 second, delta x is 20 feet, right? Yes, correct, because this is linear. This is linear. So if here we have delta t how many seconds? 1 second, and delta x how many? 20 feet. Okay, so when we analyze this motion, we have the observation like this. Okay, if the time interval is 1 second, you get the displacement is 20 feet. Okay, but if we have the linear curve like this, okay, yeah, to be complicated, you know, because different time interval, different displacement. Okay, yeah, even though we have the same interval, but different displacement. Okay, from here delta, time interval, this is 1 second, right? But this is 0, this is maybe 60, but okay, and here and 1 second next, the time interval is constant 1 second, but you know now the displacement is 20 feet. Okay, so it depends on non-linear curve like this or like this or like this. Okay, we have different displacement. Okay, but we hope you get a linear curve. You get a linear curve because we have the same interval with the same displacement. Okay. Okay. Next. Okay, now we have multiple choice, and then try to type your answers as fast as possible. Of course, you should get the correct answer. Okay, look, mirrors is at position xa 23 meter. Then she undergoes a displacement delta x is minus 50 meters. So what is her final position? Okay, 1 minute. Okay, try to give your answer and type your answer into the chat window. You get extra point. Okay, maybe 3 first persons, 3 first student get extra point. Okay, come on, 1 minute. Okay, time off. Now, look, yeah, as I mentioned before, when we analyze the position or velocity or acceleration or displacement, you need to consider coordinate. This is x, this is y. Okay, So for at the beginning, she is at the position 20 meter here. She here, okay. And then she undergoes a displacement minus 50 meters. And delta XA, XF minus XI, we discussed before, right? The final position minus initial position. And at the beginning, okay, at the beginning, she's here. That means you get XI 23 meters. And we know delta X is minus 50 meters. Okay, so you can get XF, right? XF is delta X plus XI, right? You move here to be here. Yeah, so you get delta X is minus 50, XI is 23, so you get minus 27 meter. Okay, so now if okay, after some times, okay, she move in this direction and they get minus 27 meters. Okay, so the answers will be A. Okay, A. Okay, so now I will check the answers. Oh, a lot. Okay, so just so for okay, so for TA, remember we have Nguyễn Văn Đức, okay, 1% extra boy, Lê Tấn Thành 1%, and Nguyễn Dương Khánh 1%. Okay, so yeah, after we finish the lectures, okay, come to TAs and STA to keep your actual point into the file, Excel file. So TA, please, you make some. I mean, you make some column here. For example, you type, for example, this is 19, 11, 2025. Okay, and yeah, someone gets 1%. Okay, yeah, okay, yeah, it's something like that. Okay. Oh, yeah. Oh, okay. Yeah. Yeah, we have many correct answers, but you are too late. Okay. Continue. Maybe we have more the multiple choice question. Okay. Let me. Oh, yeah. Oh, yeah, we have. Okay. So. Okay, so now, yeah, of course, we discuss about the motion in the one dimension. Okay, so for example, here we describe and analyze linear motion. Right. We have horse, and horse follows the x-axis direction. Okay. Or here we have the uniform motion. What's a uniform motion? Because we have delta t, dt I, dt tf, and they get the displacement delta x. Okay, delta t1, delta x1, and here the same time interval and the same distance. Okay, delta 2, delta x2, here delta t3, and this is delta x3. So they had the same delta t1 and delta t2 blah 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 equal to delta ti, okay, and delta x1 equal to delta x2 blah blah equal to delta xi. So we say uniform motion. Okay, uniform motion, because they keep the constant time interval and constant displacement. Okay, yeah, displacement. Okay, so from yeah. Okay, we also discussed free falling objects. Okay, yeah. Now, multiple choice question again. Now we have a bicycle is moving to the left with increasing speed. Okay, remember speed. is increasing. So which of the following motions diagrams illustrate this motion? Okay, so now 340. Okay, come on. You need to answer is okay. These multiple choice questions: A or B or C or D. Okay, 1 minute. Remember the bicycle. A bicycle is moving to the left. Okay. Okay, time off. Okay, so we need to analyze. Okay, so again, we need to have coordinate, xy coordinate, xy coordinate. And then this is origins, you know, and then they, this is minus infinite, this is positive infinite. Okay, so now you know, the bicycle is coming to the left, so that means in this direction, right? Left. Okay, so in this direction, so we ignore this one, right? We ignore this one, right? Because if we follow this this arrow, okay, you need to stay here. That means origin will be here, and then you move to the right. It is right side. Okay, and if you stay here, right, and if you follow the direction of the arrow, when we also come to the right side, so we delete it. Okay, so maybe it's question B and sorry, answer B or answer C, they will be possible to become the answers. Okay, so now if you stay here, if you stay here, and this is origin, right? This is origin. This is origin. So maybe I use this one. Y, X, and they move to the left. Yeah, correct. Okay, and then you know the speed increasing. Okay, so if the speed is sorry, so if the speed increasing, right? So if the speed increasing, that means the distance will be longer and longer. Okay, so here we have delta t, delta t1, you get delta x1, delta t2, you get delta x2, delta t3, you get delta x3. So look, we have the same time in the same time interval. Okay, but delta x3 is higher than delta x2 or delta is higher than delta x1. Okay, even though we have the same time interval, but the distance, the displacement is higher and higher, longer and longer. That means the speed is increasing, right? You know, increasing, that means the same time interval, but the displacement is bigger gradually. So if we have decreasing, if we have decreasing, that means the same time, the same time interval, but delta x3 will be less than delta x2, less than delta x1. We say the speed is decreasing, so the correct answer will be 3. Sorry, B. Okay, we delete C because you know we have the same time, but this is delta x1, this is delta x2, this is delta x3, this is delta x4, and delta x4 less than. So this is decreasing. Okay, this one is increasing. Okay, so the correct answer is B. Okay, B. Okay, yeah. Now, double check. I will check after 439. You know, before 439, I will not count because not count. Okay, okay. 439. So we have Trần Minh Chí. Okay, Trần Minh Chí, Vũ Anh Khoa, and Nguyễn Hoài An. Okay, okay. So remember when I say start, you type your answers. Okay, so here is for 340. That means I will count from 339. If you have 338, I skip. Okay, so 339. So 339 will be here. Will be here. Okay, so B. Trần Minh Trí, Vũ Anh Khoa, and Nguyễn Hoài An. Okay, congratulations, you get 1% extra point. Okay, so okay, so let me see. We have an okay, so maybe just some questions. Okay, maybe just one more multiple choice, and then we stop. All right. Okay. So now, this love at a point on a position versus time graph of an object E, the what? Okay. Remember this love. We have position versus times. Position mean x. Okay. So this is y-axis is x position, and this is x-axis is times. Okay, so this slope, for example, here we have this one, right? This is the curve of positions versus time, so we have slope. So this slope at a point on a position versus time graph of object E, the what? Okay, now start. 347. Okay, 1 minute. You know, because this is a written question, so you just think about the answers. Okay, and maybe tomorrow I will give you more theory, and then you can understand why. Just think about the answers based on your knowledge. Okay, so finish. So the answer is C. Okay, instantaneous velocity, because we consider the point of the times. Okay, so if we consider the point of a times, we take this slope. Okay, so of course this is must be instantaneous velocity, and the y. Okay, so next lectures. Okay, next class I will tell you. Okay, so maybe we stop now. Slide 23. Okay, and now I will check the answers. Okay, what times? Okay, 346. I will check from 346. Oh, 336.
You say 47.
47. Okay, sorry. 47. 47, where is this? 47. or not? Oh, here. Trường Thắng, C. Okay. Đức Dũng, C. Tuệ Đăng, Tuệ Đáng, I don't know. Okay, C. So congratulations, 3 students. Thắng, Đức Dũng, and I don't know. Okay, Tuệ Đăng. Okay, Đăng Tuệ, I don't know. Okay, so
My name is Dang.
Okay, so congratulations. And then we finish the lecture today for theory. Now, if you don't understand clearly about the lecture 1 part 1 or lecture 1 part 2, just part of lecture 1 part 2, so lecture 2 part 1, we STA. Now the time for TA. Okay, and the TA is you have 25 minutes. Okay, so from now 3:50 and you will finish at 4 and 10, 4 and 15 p.m. Okay, thank you very much to join the class today, and see you tomorrow morning. Okay, goodbye.